Okay, hello everyone. I'm making this video to explain how to set up AHR on Unreal Engine 4 and also a bit on how the algorithm works. Okay, I'm going to start with the algorithm and then move on to settings, configuration and all that stuff. So let's assume we have a scene geometry, something like that. I don't know, maybe a hill or something. I'm doing some rough painting in Paint just to explain. Let's assume we have also the sun coming from certain direction, I don't know, 45 degrees or something. I'm going to just draw an arrow there. That's going to be the sun. And okay, from that direction, let's draw where the shadows end. That small hill is going to cast a shadow onto the other part, and let's draw a line. Okay, so all this stuff that is inside this space, that's sun shadow. We have that. Let's compute the illumination to that part of the hill. That illumination is going to be computed from the parts that are lit by the sun. How can we compute that? Is we cast rays from that point. In my implementation, I cast fixed 5 rays. Well, by fixed I mean that there are similar rotations, there's similar directions, depends on the pixel on the screen and the normal. That's implementation details. And how can we compute that intersection to find out that the ray is actually hitting the sun or not? To do that and to make it so that it can run on real time, you have to approximate. What the approximation is, you actually consider the scene as a bunch of boxes or small cubes that cover the entire scene. You define a bounds for the scene and it covers the entire bounds. You will fill everything with small cubes, and then you compute the ray, you collide the ray against those cubes. You actually do that stepping through the ray to actually find which cubes are to actually find the first cube that you hit. There is an initial step to exit from the geometry, because if not you are colliding your own geometry, and then the other steps are fixed in size. The initial step is called initial displacement in Unreal Engine, and the other is called samples displacement. The number of steps you take into the array, it's called sample count. The higher the count, the longer the race. You can also increase the length by increasing the samples displacement, but you start to miss small stuff. Well, that's it. That's it for the algorithm. Let's switch over to Unreal Engine 4. For this part, I'm going to assume you already have downloaded the code from GitHub, compiled, and you can run by pressing Ctrl plus F5. I'm going to assume you already did all that. That's standard, nothing changed from the common Unreal Engine 4 code. So that's my test scene. As you can see, there are some parts that are quite fake. The blur is awful, I need to fix it. There are some limitations, I'm going to talk about them in a minute, but you can see it working. The recording software make it less fluid. That, for example, is one of the things I'm going to talk about later that are some errors. So now let's see how we set up a scene, real simple scene. Let's create a new level. That's just the standard level. Now let's add a volume, just a post-processing volume to tweak the settings. All AHR settings are inside that. And the light propagation volume, there's one part that says AHR. Now this is another different part. That second volume I'm creating, it's going to represent the bounds of the scene. You can have a bunch of them. It's going to take the one with the higher priority and the one that's closer, but that represent all the objects are inside that, and the scene gets divided in the small cubes I talked about. Inside that, the bounds of the scene that gets divided. You can set up the size of each cube in Unreal units. It's there under approximate hybrid ray tracing. It's called voxel size, I'm setting it to 10 as a default. That's a good enough value for most of times. Size of the voxel in Unreal units, it's quite self-explanatory. It's capped by a C-bar called AHR max slice size, so that if you set really big bounds and really small cubes, the amount of cube it's not goes to infinity or something like that. To make it be the bounds, you need to check defines AHR grid settings. That's just a checkbox. Enable it, and now that are the bounds for the scene. Now let's create a few objects just to see the GI better, but it's mostly already working. There's not much else to do but to set up the lights. I'm going to get that in a minute. Let me add first some simple geometry, a cube and stuff like that. Cube and a sphere. Going to talk about that. As you can see, I haven't disabled pre-compute lighting. You can have pre-compute and direct and dynamic indirect. Anyway, I created a few objects. The lighting is already messed up, but that's because I haven't defined the correct parameters for the post-processing volume from AHR. Now let's set up the lighting. You can keep it stationary or change it to movable. I'm going to change it to movable, but it's irrelevant to AHR. You do need to check dynamic indirect lighting. That's kind of a given. That's to make the engine aware. One big limitation, this is one big limitation. You need to check you need to change the number of cascades to one, only one. That's a limitation of this current alpha. Is not by chance a limitation of the algorithm. And another limitation of the alpha is that you only get one directional lighting. Nothing else affects GI except for emissive materials that you create, like you always create the same materials. Try to keep things capped to 32. As you can see there, you have some artifacts. That's because the initial displacement is way too low. I need to change the default settings. You actually need to multiply by 10 the default settings to get it to work. I'm going to do that right now. Just select the post-processing volume, go to where it says samples displacement, bring it up to, I don't know, like I said, multiply by 10, 22, and also the initial displacement to around 20 or something. As you can see, it's all tinted sky blue. That's because that's the color of the ray that gets lost, that gets out of the bounds, and the bounds are quite thin, so are quite close, so you exit a lot. That should be something like the sky color, but for now leave it disabled. I'm still working on it. As you can see, it's already working. You get reflections on that marble surface, you get illumination. Now it's going to play. As you can see, the gun illuminates the rocks there. It also creates a reflection and casts lights in there. As you get closer, it gets more stronger, and you also get that light in there. And on that show, well, that's mostly it. You don't really need to change much more. As you can see, you can have geometry being dynamic all the time, no problem. Voxelization time, it's a concern for complex scenes. Another problem, try to add some boundaries so that you don't get really thin walls, because light would start leaking through them. Well, that's about it actually. There is also one last thing I want to talk about, and that's the part where I compose the illumination with the GI. That's in a shader called AHR composite, .usf, standard Unreal Engine shader. You get a lot of stuff there. I sample a bunch of texture. I do a few multiplications and all, but you don't mind that. That's part of the normal interpolation thing. Actually, what I want to talk is about the diff and spec and how I mix both diff and spec. So that, don't mind that. Also, another thing that you might want to check or not is that where it says 3.5. That value is how strong it is, but try to leave it. How strong is the interpolation? But try to leave it there. What I really want to talk about is this part. The final color, I do it as a mix of the diffuse, that is the diffuse indirect, plus the specular, and I elevate the specular to a value that is an interpolation between 0.63 and 3.5 of the roughness elevated to the 0.75. That's, as you can see, it's far from physically accurate. I should be using the Unreal Engine BRDF that it uses microfacets. I don't remember correctly which is now. I think it's GCX or something. I should be using that code. I'm not doing it, and that's the main part of why it looks strange. But if you want to tweak this, you get that. You can change that power. It gives you more or less specular. You get that multiplier. It's the amount of specular, and that the diff.BB is the ambient occlusion. So I'm adding a bit of ambient occlusion to simulate some ambient lighting. I'm adding 0.075. You can increase that or decrease it. Then I multiply by just a multiplier to increase the strength or not, and that part is to limit the diffuse color so that it's not completely zero and blacks out the illumination. Now this is even faker than before. I mean, this is awful, but still it kind of works. I get a value that increases as much as the glazing angle increases. That's just to mix the reflections with the surface when you're looking them really perpendicularly. When you're looking them real close, when you're looking from the front, you don't get mirrored, but when you're looking from a grazing angle, you do. Now, there are some materials that are mirrors. For example, the marble default material. I create that adding the 0.18 multiplied by the roughness, elevate to 12. That's just so it works. And then I finally just lerp. Why I want to talk about this, so that you can see how fake it is for one side. That's, I recognize that, but also how can you mix stuff and arrive to a better approximation of how it will mix in real life. There is also some math problems with the interpolation. It's sometimes wrong, especially on the specularity. Specularity is wrong from time to time. I do know how to fix that. I haven't just done it. It's not difficult. I just need to handle a few cases different. And the math answer is because I'm creating an orthonormal basis from just one vector, and there are infinite, so I need to choose one of them, but I need to preserve some orientation, so that's not trivial. I need to just do some cases by hand, but it's actually easy. So this is it. I will post all this on the forums, and well, you can put all the comments, all the suggestions, everything there. The code is on GitHub, it's public, so you can download from there. Well, that's it.